Good evening. I'm Carol Silver Elliott. I'm President and CEO of the Jewish Home Family, and it is my very great pleasure to welcome all of you here this evening. Some of you may know that 2017 marks the 200th anniversary of the first diagnosis of Parkinson's disease, the naming of Parkinson's disease. So we thought this was a very fitting way to kick off both that year anniversary, but also our program at the Jewish Home Family that's really focused on improving and enhancing the care of individuals with Parkinson's. We embarked on this journey several months ago, and we're delighted to have a couple of wonderful partners with us. One is the Michael J. Fox Foundation, who have been incredibly helpful with respect to identifying resources and really helping us to learn the latest and the greatest about what's out there in the world of clinical protocols. We're delighted also to be partnering with our friends here at Englewood Hospital and Medical Center, and you'll hear from Dr. Gary Allweiss later. Dr. Allweiss has been enormously helpful with our work to make sure that we are providing the best possible care for our patients and our community, individuals with Parkinson's disease. Our program tonight will consist of a presentation by Dr. Chahine, whom I know all of you have come here to listen to, and we will follow that with a panel of experts, so it'll be an opportunity for you to ask questions and get a little bit more detailed information. I'm going to introduce to you Dr. Lana Chahine. Dr. Chahine is a neurologist who received subspecialty training in movement disorders and sleep medicine at the University of Pennsylvania. Dr. Shahine's clinical interests include identification of biomarkers for Parkinson's disease and individuals at risk of developing Parkinson's disease, the causes, consequences, and treatment of sleep problems in Parkinson's disease, and clinical trials to improve quality of life through treatment of motor and non-motor symptoms in Parkinson's. Dr. Chahine is also involved in education via her role in the University of Pennsylvania's Movement Disorders Fellowship. The Michael J. Fox Foundation was kind enough to help us identify and entice Dr. Chahine to come here to be with all of us tonight. So we thank them, and we thank her, and we thank all of you.
Can everyone hear me okay? Thank you for having me here today. I'm very happy to be here. Thank you to the Jewish Family Home for inviting me, and for the Michael J. Fox support, and for hosting us here in this great venue. Today I'll be speaking to you about the genetics of Parkinson's disease, as you know. I'll also be talking about an exciting research study that aims to investigate the genetic aspects of Parkinson's, among others, called the Parkinson Progression Marker Initiative, and I'll talk to you about how you can get involved. So I'm going to start by telling you a little bit about what Parkinson's disease is. It's a neurodegenerative disorder, and the term neurodegenerative means that there's loss of nerve cells in the brain. And it's the second most common one after Alzheimer's disease. It's thought that about 1 million individuals in the United States are affected with Parkinson's and 5 million worldwide, though this is projected to increase dramatically up to 10 million as soon as 2020, 2022. So the typical motor symptoms of Parkinson's disease include tremor that is present in most but not all who suffer from it, stiffness or rigidity, and slowness of movement. And the slowness can be in general movement or in specific movements of the hands, feet, or with walking. And then there are several other what we call non-motor symptoms, symptoms that do not involve motor function. So there's a wide variety of these. They range from psychiatric symptoms like depression, anxiety and memory loss, constipation and various sleep problems, as well as a loss of sense of smell. We don't know what the cause of Parkinson's disease is. We know several components to the pathophysiology, but we haven't yet brought it together. And we think that genetics play a very large role in Parkinson's, though again, only a small proportion of people with Parkinson's disease right now have a genetic cause, or Only 10% of people with Parkinson's in general have a genetic cause identified, but we think that your genome, your genes in general, probably contribute to most people with Parkinson's. And the reason we're so interested in genetics is because we believe that eventually we'll be able to have targeted therapy, so that if someone has a specific genotype, genetic mutation or otherwise, we'll be able to treat them based on that to hopefully slow the disease down or stop it or prevent it. This is all under the umbrella of disease modification. That's the biggest need today. We're good and getting better at treating the symptoms, but now we're aiming to modify the disease to stop it, slow it down, or prevent it. So as I mentioned, the cause of Parkinson's is unknown, and we think that in most people, genotype contributes and then environmental factors interact with genes to cause the disease to manifest. And there are certain subgroups of people with Parkinson's disease who are more likely to have these genetic mutations that are readily identifiable and thought to be directly related to the cause of Parkinson's. So now I'll move to talk a little more about that. There are two genes I'm going to be speaking about. One is LRRK2, or we call it LRRK2. It stands for a very long, irrelevant name, so I won't tell you what it is. But this gene was discovered in 2004, and I mean, in just the brief period, 12 years that it was discovered, we learned so much about it, and there's so much more yet to be learned. It is the most common genetic contributor to Parkinson's disease known to date, and it's inherited in what we term an autosomal dominant fashion, so that multiple people in the family may carry this gene and manifest Parkinson's. And having a mutation in this LRRK2 gene is more prevalent in some ethnic groups. So this is a map where you see the percentage of all people in a country with Parkinson's, the percent of those who would carry the LRRK2 gene in North America, compared to here, North Africa, Europe, Israel, South Africa is just 2%. So let's look at some numbers. So North Africa, and specifically areas of Libya, and where there are people of the North African Berber ancestry, 36% of all people with Parkinson's there carry this mutation. And if you take just familial forms, people with a first-degree relative, 42% do. And among Ashkenazi Jews who live in the Middle East, 28% of those will have carry a LRRK2 mutation, and that demographic is thought to be similar in the United States, though not exactly. And in other parts of the world, as you can see, this mutation is very rare. So if you have a LRRK2 gene, you have a 50% chance of a gene mutation, you have a 50% chance of transmitting that to your children. Now, what is LRRK2? It's a gene that codes for an enzyme, and this enzyme ends up being overactive when you have the mutation in Parkinson's. And that's actually good news, because it's easier to slow down an enzyme than speed it up. If we can find ways to slow down this enzyme activity of the LRRK2 gene enzyme, we can actually hopefully help treat its contribution to Parkinson's disease. And this is expected to benefit people with the mutation with Parkinson's, but also people without. So the LRRK2 gene, even when not mutated, may have some relevance in the causes of Parkinson's. So that's what I'm going to discuss for LRRK2, and then I'll talk about the next gene, GBA, and then I will speak more broadly just in terms of genetics again in Parkinson's. So the GBA is a gene that causes Gaucher's disease. Gaucher's disease is a disease that involves the blood, it involves the bone. It used to be thought to not be related to neurologic disorders at all, but more recently we found that the same gene that causes Gaucher's can also cause or contribute to Parkinson's. So Gaucher's is what we call a lysosomal storage disorder. The lysosome is the part of the cell that clears up, it's like the garbage disposal of the cell. And in Gaucher's disease, there is an abnormality in lysosomal function, so that there's accumulation of some toxic products. And it's common, it's 1 in 20,000 individuals to 1 in 100,000 are affected with Gaucher. And unlike LRRK2, where the enzyme is overactive, and in the GBA gene, the enzyme underactivity leads to disease or other abnormalities. And also unlike LRRK2, it is recessive in the Gaucher sense, in the sense that you have to have 2 mutations to have Gaucher. But only 1 mutation is required to be related to Parkinson's. So, not to be related, but to have a link to Parkinson's, you only need 1 gene abnormality. So, as I said, Gaucher's is very common. It's the most common inherited Jewish genetic disease. Approximately 1 in 500 to 1 in 1,000 Ashkenazi Jewish individuals have Gaucher, and approximately 1 in 18 are carriers of a GBA gene. That's very, very high. Now, not everyone who has the GBA gene mutation goes on to get Parkinson's, and I'll be going back to that later. So, Parkinson's disease is more common among individuals of Ashkenazi Jewish ancestry, and the GBA gene mutation is also very common, and that led to looking for a link between the two, and it was found. So approximately 20% of people of Ashkenazi Jewish descent who also have Parkinson's carry the mutation versus just 7% of those who do not, those who are not Ashkenazi Jewish. Like LRRK2, each individual who carries the GBA gene has a 50% chance of transmitting that gene to their children. And so it's important here to think that, as you saw, 1 in 18 individuals who are Ashkenazi Jewish carry this gene, and 30% of individuals with Parkinson's carry the LRRK2 gene, but a much larger proportion of individuals of Ashkenazi Jewish descent carry these genetic mutations. So the question is, and not all of them get Parkinson's, so there's a term called penetrance. It's when you're talking about if someone has a gene that can cause disease, in what percentage of people does the gene actually cause disease? So there are some genetic mutations that are fully penetrant, 100% penetrant. If you have the genetic mutation, you are definitely going to get the disease. This is not the case for these 2 genes. Only a subset of people with these mutations get Parkinson's. And this is the importance of studying these genes, because the question is, who has these mutations? But most importantly, who will get Parkinson's? Why do people differ? What affects why one person will get Parkinson's and one person won't if they have a mutation? And what is the role of the environment? What is the role of other genes in this? And this is where families of individuals of Ashkenazi Jewish heritage have a very important role to play in Parkinson's disease research to help us understand these questions better. So, by studying people with and without Parkinson's disease who have a LRRK2 or a GBA gene mutation, we can better understand, again, why some people go on to develop Parkinson's and others don't, track more subtle symptoms and try to identify Parkinson's earlier and earlier, and develop new treatments. And here I just want to reiterate again that I think that you might say, well, if the mutations only affect a certain percentage of people with Parkinson's, why focus on them? And I, again, believe that even though the people with the genetic mutations probably have the lowest or highest enzyme activity and are most affected, I do believe treatments developed for these genes will later on go on to benefit the broader Parkinson's population. So this brings me to the Parkinson Progression Marker Initiative. So as I said, there are many more people who carry these genetic mutations than go on to develop Parkinson's, and we really need ways to identify who will develop Parkinson's and when and why. So the Parkinson Progression Marker Initiative is a clinical study, it's a landmark study, it's revolutionizing the field of Parkinson's disease. It is really contributing tremendously to our understanding of the disease, to diagnosing it, and predicting it over time. Now, when PPMI started a few years ago, the goals were to generate research that would ultimately allow for earlier diagnosis, better disease tracking, and more efficient testing of new therapies. And this latter point, the last point, is key. So, for decades now, as you mentioned, Parkinson's disease was first described in 1817, and here we are 200 years later, and not yet without disease-modifying therapies. And it's thought that part of that is that we are not good at measuring the disease. So one of the reasons the PPMI study was put together is to find objective tests. Just like you go, you get your cholesterol checked, you have a number, you take a medication, and you can target that number. That's the goal ultimately for Parkinson's. So it's an observational study, meaning there's no intervention, there's no drug treatment being given, and it is over a $60 million study sponsored by the Michael J. Fox Foundation. The Michael J. Fox Foundation is the single largest funder of Parkinson's disease research. We're very lucky to have their support. And this PPMI study is taking place at 33 sites worldwide right now. So it's all over the world, and in Australia, Europe, and several sites in the United States. So as I said, in 2010 when it was launched, it had the goal of recruiting 400 individuals with early Parkinson's disease and 200 healthy controls, individuals without Parkinson's. And the study went very, very well when it first started, to the point where these 600 individuals, enrollment was completed by 2013. And so there was this incredible infrastructure in place, everyone was working very well together, and a very unique aspect of this study is that the Michael J. Fox Foundation, their condition for funding it was that any data generated from the study would be available to researchers, any qualified researcher, to use the data, which is very exciting because then it's not just limited to the investigators at the 33 sites recruiting patients, but at hundreds more academic centers and pharmaceutical centers across the world to take this data and identify biomarkers and analyze it and generate important findings. So because it went so well, the next step was to think about how can we take the infrastructure we've set up, what we've learned so far about recruiting, about doing the procedures to collect all the fluids we're collecting and data, and extend this to not only people with Parkinson's, but people at risk of Parkinson's. And with the goal of, again, trying to identify these at-risk individuals, who's going to develop Parkinson's, and eventually the long-term goal is to prevent Parkinson's. So the study first expanded to include two groups of individuals, one with a loss of sense of smell, because we know that in Parkinson's disease, over 90% of individuals affected by it have a loss of sense of smell, and that precedes Parkinson's by years to decades. So thousands of people were screened for a loss of sense of smell and then had some additional tests, and a subset qualified to participate. The second group of individuals enrolled had a sleep disorder called REM sleep behavior disorder, where they acted out their dreams. So those groups were relatively small, but they're going to be very informative. And then in 2014, the genetics arm was launched. So this aimed to recruit individuals who have the mutations, the LRRK2 and GBA mutations. And this is recruitment for that arm of the study is ongoing. And to be more specific, people with the LRRK2 and GBA mutations are being recruited whether or not they have Parkinson's disease. So we're looking for both groups of people. And the goal is to enroll 500 individuals with one of these mutations. And the study has been a great success so far, but to continue being able to succeed and to enroll 500 individuals with these mutations, which is a very ambitious and yet doable goal, that's where individual volunteers are needed. So I'll put a few plugs in for this, but the first, I'll just mention this website, and there's also some cards at the desk where you came in, but michaeljfox.org/ppmi/genetics, that's the website. And we'd really appreciate if you could share the link with your family too. And I'll go back a little more and talk about who specifically might be eligible for this study. So as I said, we're looking for individuals with or without Parkinson's who might have these mutations. So you may have Parkinson's disease, and Parkinson's disease, if you have these mutations, you won't know it. Your Parkinson's is probably not different from an individual with Parkinson's disease who does not have this mutation. It's probably not different clinically, but there may be certain differences that will later inform treatments for people with these mutations. But so we're looking for individuals either with Parkinson's disease who are Ashkenazi Jewish ancestry. Those are the only criteria for people with Parkinson's. They're older than the age 18. So if you have Parkinson's and you're of Ashkenazi Jewish ancestry, you will qualify to have genetic testing for the study, and we'll go back to that. And then we're also looking for people without Parkinson's who carry these mutations. So if you are of Ashkenazi Jewish ancestry and are 45 years or older, and you either have a first-degree relative with Parkinson's or a first-degree relative with Gaucher's disease, you would also potentially qualify. So again, participation of family members is very important. The study is really working to try to identify families of people with the mutation because those people are also more likely to carry it. And so we're really, in order to succeed in researching genetics and Parkinson's, and especially among individuals of Ashkenazi Jewish ancestry, not only do individuals with Parkinson's disease, not only do we need them to participate, but we also need their family to participate, to volunteer. So what would it involve if you were to participate? I just want to mention that the first step, you can do it from your own home. You don't have to go anywhere. You just have to, you do it from your home using a computer or making a telephone call, and everything will be done over the phone and by mail. So if you take a brief survey online, it will be determined whether or not you are of Ashkenazi Jewish ancestry and you have Parkinson's or a first-degree relative with Parkinson's or Gaucher, and if that is in fact the case, you will receive more information, and if you're interested, you'll receive a kit that you'll just swab your mouth to obtain saliva, and it may not actually be a swab, it may be a saliva sample. You actually have to provide saliva into a kit, and then it's analyzed, the DNA is analyzed, you mail it, the DNA is analyzed at a very qualified lab, and as part of this, you'll receive genetic counseling. And genetic counseling is very important because a lot of people, you may be sitting here, you either have Parkinson's or you have a family member with Parkinson's and you're very eager to help, but there are important questions to consider. What does it mean to have the gene mutation? What are your risks of Parkinson's if you have it? As I mentioned, it's not 100%. And what does it mean for your family and so on? So it's very important to ask all these questions and get answers and be comfortable before you proceed. But if you end up doing the genetic testing, which we really hope you will, and if you have a genetic mutation, what will happen is that you will be invited to participate, so you will be told that the results will be revealed to you if you want. If you have Parkinson's, the results have to be revealed to you. If you don't have Parkinson's, you can opt to not receive the results but still participate in the study. So we have both healthy volunteers and people with the mutation, so you won't have to know if you don't want to. And there are, as I said, 33 sites across the world, so you would be told, here are the sites near you. We have several in New York, at least one in New York, in Philadelphia, and Baltimore, several in the region. And so you'd go then to a site where this research is being conducted, and you would undergo various evaluations that I'm happy to go into in detail if you're interested, but it's sort of down the line. A lot of it involves questionnaires and physical examinations and collection of biofluids to identify biomarkers. So all costs associated with activities that are part of this study will occur free of charge. And this is really because of the support of the Michael J. Fox Foundation and their industry partners. You will not need to disclose your results to the health insurance company or to anyone if you don't want to. There is a Genetic Non-Discrimination Act that should protect people who know they have a genetic mutation from discrimination, from health insurance discrimination, otherwise. But still, you don't have to tell anyone of this, of your results. Okay, I misinformed you, I'm sorry. Actually, everyone who has genetic testing has to be informed of their results. So it's not that if you undergo this testing, you need to be ready to receive the results. So you need to think about whether or not you're going to be anxious if you find out you have a mutation and about your future risk of Parkinson's. And there there's a lot that goes into research studies to try to protect your identity, to protect your information. It's all heavily password protected, and we have we don't really have concerns about security breaches, but as you know, they happen. So these are all considerations you need to think about. So, as I said, the website is michaeljfox.org/ppmi/genetics, and this brochure is out at the table out front. And please share this information with your family and friends. So I'll repeat one more time. If you have Parkinson's disease in your Ashkenazi Jewish ancestry, you automatically qualify for this. And if you are of Ashkenazi Jewish ancestry and have a first-degree relative with Parkinson's or Gaucher, you also qualify. And please help us distribute this to your local community as well. So thank you for being a partner in Parkinson's research, and thank you for coming today. I finished up a little early, but
While our panelists are gathering, Dr. Chahine will be on the panel, and you can move around your name tags and sit wherever you like. She's being joined by Dr. Gary Allweiss. Dr. Allweiss is the Chief of Neurology at Englewood Hospital. He graduated summa cum laude, Phi Beta Kappa from the University of Pennsylvania, and was AOA Honor Society President in medical school. He was chosen as chief resident during his training at Mount Sinai Medical Center and completed a fellowship in EMG and neuromuscular diseases at Columbia Presbyterian Medical Center. Sitting next to Dr. Allweiss is Vanessa Arnedo. Ms. Arnedo is the Director of Research Partnerships for the Michael J. Fox Foundation. Vanessa graduated with an MPH in epidemiology from the Mailman School of Public Health at Columbia University and holds a BA in sociology from New York University. She joined the foundation in 2013 after spending almost 3 years at SUNY Downstate Medical Center, managing recruitment and clinical trial operations for several multi-center studies, and served as project director for the NeuroNext Clinical Trials Consortium. And last but not least is Dr. Harvey Gross. Dr. Gross is the medical director of the Jewish Home at Rockley and chief of family practice at Englewood Hospital and Medical Center. He is board certified in family and geriatric medicine. Dr. Gross is a member of several professional societies, including the American Geriatric Society and American Academy of Family Practice, and he was also named in New York Magazine's Best Doctors. So we have our panel of experts, and I thought perhaps each of them might have just a few words to say, and then we'll open it up to questions. Do you want to start, Dr. Allweiss?
No, yeah, sure. Thanks everybody for coming, and thanks for that wonderful lecture.
Use microphone.
Thank you, everybody, for coming, and I was echoing how it was a wonderful lecture, and I appreciate the Michael J. Fox Foundation. I'm in a neurology group here in Englewood, and we do a lot of work at Englewood Hospital, and we see all kinds of neurological illnesses, and Parkinson's is one of them. And as it was said, we have a fair amount of symptomatic treatments, but we'd like to do something more than that, and we're excited about that as well.
Thank you, everyone, for coming out. I'm Vanessa Arnedo from the Michael J. Fox Foundation for Parkinson's Research. And I also just want to thank my panelists, as well as the Jewish Home and Englewood Hospital for organizing this wonderful event, and to you all for coming out. The foundation is, as Dr. Chahine said, the world's largest nonprofit funder of Parkinson's disease research. We have funded over $600 million in research with the goal of accelerating better therapies for people living with Parkinson's today. And the real sort of holy grail, so to speak, is what Dr. Chahine was talking about, is disease-modifying therapeutics. So there are a lot of treatments on the market that treat the symptoms of Parkinson's disease, but there is currently nothing that will slow or stop the progression of Parkinson's disease. And if nothing else, I would just like you to sort of take away from this talk the ways in which this particular research study, the Parkinson's Progression Markers Initiative, is really working to try to accelerate the development of disease-modifying therapeutics. One of the ways is, as Dr. Chahine said, being able to look at people that have these genetic mutations and understand better why do some people go on to have Parkinson's disease and others don't. Is there some pathology there that potentially is protective that we should be thinking about in terms of targets? The other is that this is a biomarker study. So a biomarker is a substance or characteristic that's in your body that's associated with the presence or the progression of a disease. And there is currently no biomarker of Parkinson's disease progression. So many of you may know this if you yourself have been diagnosed with Parkinson's, or someone in your family has been diagnosed. You don't just go to the doctor, you get a Parkinson's test and they read it out and tell you have Parkinson's disease. It's much more complicated than that. And so the lack of a biomarker is an issue for diagnosis, but most importantly, it's a very major obstacle for that development of potentially disease-modifying therapeutics, because if you were to have a clinical trial with a therapy that you thought was potentially disease-modifying, if what you're measuring as part of that trial is not quantitative, and you have to then have a larger study for a longer duration, a biomarker could really transform the field of Parkinson's disease research in terms of the types of trials that we could have, and we could do this faster and actually cheaper as well. So, I just wanted to sort of reiterate to you all that that's really what this is all about, is really trying to accelerate the drug development pipeline, particularly for disease-modifying therapeutics, and of course, ultimately, a cure.
Well, thank you everybody for coming out this evening. I too found this to be a very interesting lecture. And I just want to say at Rockland, we're dedicated to developing a program, a comprehensive program to treat Parkinson, inpatient, outpatient, utilizing physicians, neurologists. We have all this available, physical therapy, dietary, social work, psychiatry, psychology, and we've been working on this program for quite a while, and also going to develop a program for outpatient as well, and it's a pleasure to be here tonight.
We can open it up for questions. Does anybody have a question? I see a hand over here, Tracy.
Is medication the only treatment for Parkinson's, or do you have other methods of dealing with the disease?
That's a great question. The question was, are medications the only treatment for Parkinson's? The answer is no. There are certainly several modalities of treatment. Medications are a cornerstone. So as many of you know, Parkinson's disease is due to low dopamine in the brain, and dopamine and other chemicals, and all these chemicals are involved in various functions. And we're very fortunate to have dopamine and other chemicals in pill form so we can replace the chemicals. But that's a big part of it, but it's not all of it. Physical therapy is a very big component of Parkinson's disease treatment. There are now highly specialized and therapies that are proven to be effective, as well as occupational therapy and speech therapy. And there are several surgical treatments for more advanced stages of the disease as well.
I understand that the Jewish Home is starting a program with boxing. Could you explain that to us, please?
I can. And you all know about it, actually. One of the things that has been so exciting for us in all of the work we've been doing learning more about Parkinson's is that we talk to people all over the country, and they tell us something that we didn't know before, and we research that, and the next person tells us something else. So we had the opportunity to learn about a program called Rock Steady Boxing that was actually developed in 2006 in Indianapolis. It's a program that really uses the intensity and the movements that are used in training boxers to work with Parkinson's patients. There's a program in central New Jersey that we went to visit that we all got very excited about, and We look forward to starting the program as soon as we can get our folks through training. We can't get them in until March. If you know anybody with Route Steady, you can get us in earlier, but we're signed up for March, so we're looking forward to starting that program in the spring.
I just want to add one other thing. That we're probably the only facility in Bergen County or northern New Jersey that's concentrating on Parkinson's disease and developing this comprehensive program.
Can the presence of the gene be detected at birth?
Yes, we are born with, in the vast majority, the very vast majority of the answer is yes. There is what is termed a sporadic mutation, so you may have the gene and no one else in your family may have it, but if, for example, someone carries a gene and they wondered if their future child may have it, it can be tested in the fetus even. In the vast majority will be positive. Excuse me, not the vast majority, 50% of children of people with the mutation will have it.
Can you tell me how do we know whether we have the mutation? Because I was just diagnosed with Parkinson's, but I didn't even know about it.
Yeah, so if you have Parkinson's disease and you have the mutation, your disease does not differ in any way from someone without the mutation. So you can't really tell from your symptoms or from any of your characteristics. The only way you can tell is by getting genetic testing. Now we hope that in the future we'll develop biomarkers so you could just get a quick blood test or a urine test. But right now the only way is genetic testing. Genetic testing so for this, there's different ways. A sample of DNA needs to be obtained. That can either be obtained with a blood draw, or if you do it through this research study, and you qualify, you'll be mailed a saliva kit, provide a sample of saliva, it'll be mailed to a lab, and the DNA will be sequenced to see if you have the gene. A gene mutation is something that's in your genome, in your DNA.
I'll just add that the doing genetic testing for these particular mutations is currently not part of the clinical testing because, as I said, there's no disease-modifying therapy that you could take if you found out that you had the gene. That we're not there yet. So the only reason right now to do this genetic testing is to participate in research. So that's a personal choice that people need to make, but ultimately that would be the sort of reason to get testing, and that's why it's not part of the clinical care.
I'd like to participate in the test, but I'm half Ashkenazi, half Sephardic. Do I still qualify?
I would actually recommend calling the number that's on the flyer and that was in Dr. Shahine's presentation and talking to the research team that is doing this, and they can advise you whether or not it makes sense or not.
The fastest growing area in cardiology right now is preventive cardiology. So, and then the other question that stuck out was if in the United States of America, 3% have the mutation, but we're 20% of the worldwide cases. Is there any mechanistic speculation about why? Is there any isolation from an environmental kind of nutrigenomic standpoint? And then is there anything identified or in the works or even speculated on prevention?
These are great questions. So first, in terms of prevention, unfortunately right now there are not targeted treatments. That is one of the main goals of the PPMI study, is to first identify, to learn how to measure disease activity and then later to prevent it. But we believe that there are certain lifestyle decisions and factors that may help. So we believe now that, for example, exercise is considered neuroprotective. There's now evidence that exercise helps prevent dopamine cell loss. Treatment of cardiovascular risk factors is encouraged, and then avoidance of any environmental risk factor known to contribute to your risk of Parkinson's. So that might include pesticide exposure, certain industrial chemicals, and while no one goes out to sustain head trauma, I think that if you are known to have a risk, you particularly want to take measures to avoid head trauma. You might stop playing contact sports, and I just, rock steady boxing is super safe, so there's no head trauma there. It's not like regular boxing. In terms of your question about, so I may have misstated, so the prevalence of genetic mutations in Parkinson's individuals with, or populations with Parkinson's disease varies worldwide, so that it's 30% of individuals with Parkinson's disease who are Ashkenazi Jewish have this mutation, have the LRRK2 mutation, and it's thought to have this founder effect, where thousands of years ago, it's estimated 4,000 years ago, individuals who are the ancestors of the present day Ashkenazi Jews developed this mutation de novo. Their DNA created it, and they started to pass it on along generations. And this mutation was also thought to arise in two other founders worldwide. So it's not, so there are other populations who carry this mutation and they had a different founder, but I don't know if that answers your question.
Have there been any testing in that community which has engaged in intermarriage, the Ashkenazi community, versus, let's say, the more Orthodox community where there isn't intermarriage? Has there been any findings that the incidence of inheritance, so to speak, is larger in the Orthodox community than in the intermarried community?
To be honest, I'm not sure, but I think that in general, if they're in communities where there's more intermarriage, that certainly the gene would be more likely to be prevalent, but that's just a generalization. So it is actually, that's why we really focus on individuals of Ashkenazi Jewish ancestry, as opposed to other Jewish groups.
No, but it might be an interesting thing to follow up to see from the Ashkenazi when there's intermarriage, then there's less likelihood of both of them, I guess, I don't know, carrying the thing.
Right.
Tracy, there's a lady right here who's had her hand up for a very long time in the middle. Thank you.
My husband was diagnosed with Parkinson's about 7 to 8 years ago, and we've been going to the Columbia Neurological Institute, and it's a wonderful facility which has a great reputation, but as far as I'm concerned, I just don't understand why we don't get specific answers. Why does it take so long? Or why is the field of study in this particular area only become so dominant today in comparison to a few years ago? I mean, it's a disease that's been identified in 1870. I mean, that's a long time ago, and I know we made a great deal of progress in many diseases, but it's very frustrating from the point of view of my own family, and specifically what I've observed with other people. Some people are suffering a great deal. We've been very fortunate so far. But I had a cousin who ultimately wound up in a nursing home, and he was part of studies. So it's very frustrating from my point of view. And why is it taking so long?
I share your frustration. I wish it could go much faster. I wish we were here talking about a way to prevent the disease with medications already, but I think there are several factors. One is the realization that we don't know how to measure the disease yet. I think that is the key component to our research, is the PPMI study should have been done in 1817, to start off. The other thing, and then I'll pass it to Vanessa, is a lot of the genetic mutations were identified in the past 2 to 3 decades. The first time Parkinson's was ever linked to a gene was in 1997. And the LRRK2 gene was just identified in 2004. And the link between GBA and Parkinson's was not really consolidated until about 2005. So it's really just been, but so then, the good news is since then there's been this dramatic acceleration in research.
Yeah, no, I concur with that. I think, as I said, a major obstacle is the lack of biomarkers. And, thinking about past trials, it is possible that, those trials just could not continue or, did not show any significant results because what you're measuring in the trial is, you don't have any faith in it. And so again, I think, actually having these measures will really, I think, change the game in terms of, the speed at which we can accelerate the drug development. The other piece is, why does this take so long? Clinical trials are a critical part of the drug development process. And I have to say that the reason that they take so long is because you can't get enough volunteers for this study, which is such a shame and is, I think, one of the things that the Fox Foundation is really invested in. And, we did a survey of the Parkinson's community, and 75% of individuals said that they would be more than happy to participate in a trial, but only 10% actually do. And so one of the, if this particular study does not apply to you, you're not interested in genetic testing results, please visit foxtrialfinder.org. This is basically match.com for Parkinson's disease clinical trials. Every trial that is related to Parkinson's disease will be listed there, so it's a one-stop shop resource. Please share it with family, friends, anyone who cares about Parkinson's disease. Trials are always looking for more participants, and it's just a matter of finding all of the people that want to participate to actually be able to participate in a trial.
My cousin was engaged in research. He was living in Washington, D.C., and he actually worked for the agency that does a great deal of studies in government. And his family possibly feels that his engagement in clinical studies caused more damage to him to make his disease. I mean, this is actually what I was told, that the progression of his disease might have been, hastened because of the medications that he was taking while involved in studies. I mean, is that an actual fact? Is that a possibility?
So right now, it depends on what the clinical trial was, but the current treatments for Parkinson's disease, the standards of care certainly do not accelerate the disease. There used to be some concerns, and I would say it's really the myths that have been completely debunked, that medications like levodopa or Sinemet, at one point they were thought to be toxic. That is not the case. If anything, they protect nerve cells. But it would really depend on what clinical trial. There are certain risks that come with participation in clinical trials. So of course, anytime you participate in any research study, this and others, PPMI, it's very important to be informed, to really consider what the risks and benefits are. I think that actually the best reason to be in a research study is out of altruism. I think that a direct benefit is unlikely, and sometimes it's going to be nothing more than an inconvenience to do the study, but it's really trying to help science is the main reason to do it.
I wanted to add why I think some of our patients I know are frustrated. We'll see a patient with Parkinson's, and we'll either stay on the same medicine, add another medicine, or increase the medication, tell them they're doing fairly well, see them again in 3 months, and really nothing happens in between. And so part of my excitement about this, as Dr. Gross said, is having a program where people can actually do positive things in between our just waiting for our 10 or 15-minute appointment where we just change the medication. So that might be something will be something very helpful when we get this going.
Dr. Always, do you find that you have patients that are interested in participating in the trials? Are they looking to participate, or are they reluctant?
Yeah, there's definitely some. Certainly many of them ask for support groups and ask for organizations and ask for exercises and whatnot. And there are some that ask for clinical trials. I don't really bring it up all that much, but it's something that certainly could be further talked about.
Thank you. Do you have another question?
Yes. I have a question regarding selegiline. Is there anything further known about the possibility that it does go towards reducing the progression of the disease?
So the question was whether selegiline is nerve protective, it slows the disease down. So this is a class of medications that includes selegiline and rasagiline or Azilect. So my response is that right now there's no evidence to support this, but I suspect these drugs may later be revisited when we have a biomarker, because they showed a lot of promise. So it may have just been the way we were measuring the disease that prevented us from confirming this. But right now, there is no evidence that they're neuroprotective, but they can be effective for symptoms.
Hi, thank you for doing this evening. It's been incredibly informative. I'd like to know if there's a connection between Lewy body dementia and Parkinson's, and if so, are your studies incorporating some information regarding that?
That's a great question. The Lewy body disease is a broad term that encompasses individuals who have dementia and Parkinsonism. So dementia with Lewy bodies and Parkinson's disease dementia. Lewy body disease, when an individual dies and their brain is looked at, there's structures in there called Lewy bodies, and that's what defines the disease. So people with Parkinson's have Lewy bodies, people with dementia with Lewy bodies have Lewy bodies. It's a pathologic hallmark. And Lewy bodies contain a substance, a protein called synuclein. It's a protein that has clogged up the cell's garbage disposal, the lysosomes, those structures we talked about, and probably lead to neuronal cell death. So we believe that I think the term spectrum is a good one to use, that these occur along the spectrum, and there are certainly shared mechanisms. So the GBA gene mutation that I mentioned at length has been linked to dementia with Lewy bodies for sure. So people with this mutation are at an increased risk of Parkinson's, but also at an increased risk of dementia. And I think, though that in some ways is scary, it is also, to me, a positive thing, because once we find a way to treat the GBA mutation, that treatment is going to extend to so many more people than just those who have Parkinson's. It's going to extend to people where we're trying to prevent Parkinson's and people who have dementia with Lewy bodies, and just a much larger group of people. And I just want to mention here, for some optimism, there are actually clinical trials being organized right now as we speak to try so a drug company is interested in trying a therapeutic agent, a medication, to try to treat individuals with Parkinson's and a GBA mutation. So this is not like science fiction, like, maybe 5 or 10 years from now. This is actual reality. So the hope is that if this drug succeeds, it will be tried on people, for example, with the mutation who don't yet have Parkinson's, to see if we can prevent it and prevent dementia with Lewy bodies and other disorders.
I'm Dr. Miriam Warman from William Patterson University, and first I want to thank the panel and the prestigious presenters. I wanted, as a biochemist and professor of biology, to just address the question of whether an intermarried couple would have less to worry about with regard to the gene, and just clarify that the LRRK2 gene is inherited as an autosomal dominant. A dominant gene means that it will be expressed if you inherit it from even one parent. And so if it's in the lineage, it could very well be passed down in a couple where one individual is Jewish and one is not. I thought that was an important point to make.
Thank you.
Hi, thank you very much. I gotta be honest, I'm genuinely confused about the presentation. So I'm just trying to understand the basic numbers here. So you said that there's 5 or 10% of all Parkinson's cases are linked to genetics, right?
Yes, if you pull all the people with Parkinson's combined.
Right, and of the people who have Parkinson's, let's say Ashkenazi Jewish descent, 30% have the LRRK gene mutation, is that correct?
Correct.
So the people who don't have the LRRK mutation, is there any way to find out if they have any predisposition to Parkinson's other than, I guess, family member and falling into the 10% number? And secondarily, if you have the LRRK2 gene mutation and you don't get Parkinson's, which I guess is a substantial number of people, are there any other symptoms you display that would be of cause of concern, or is there any I don't don't use the word bad, but bad byproduct of having this gene mutation other than ultimately you may get Parkinson's?
These are great questions. To answer the second one first, I think that generally the answer is no. There are a few case reports of different people with different diseases having had the LRRK2 mutation, but it is so common that I don't know that, to my knowledge, I would say there is no proven association between LRRK2 and any other disease besides Parkinson's. So 5 to 10% of individuals with Parkinson's disease overall have a genetic mutation. This increases dramatically if you're Ashkenazi Jewish or if you're an individual with young onset Parkinson's. And there are over 10, I think there are now, I would say 13, but maybe even 15 other proven genetic causes of Parkinson's. So today we're focusing on LRRK2 and GBA because those are common in individuals of Ashkenazi Jewish ancestry. There are certainly ways to get genetic testing outside of the research setting. Most of the big Parkinson centers have genetic counselors where you meet with them, they talk to you about the different mutations and get some information from you. And there's commercially available genetic testing that you could get done.
Just one more final question. So there's a probability of you having the gene depending on if a family member of yours has Parkinson's, I assume, right? What if you have multiple members that have Parkinson's? Does that number change dramatically?
Yes, so if you have familial Parkinson's, the probability of a genetic mutation being present is very high. The currently defined genetic mutations account for a large proportion of familial Parkinson's, but certainly not all of it. So in other words, there are genes left to be discovered for sure.
We have time for one last question.
How does a diagnosis of Parkinsonian disorder fit into this discussion tonight in terms of both the study participation and the adjunct treatments that you're suggesting?
So the question was, how does a diagnosis of a Parkinsonian disorder fit into this discussion today? So the term Parkinsonism or Parkinsonian disorder, these are terms we often use. This is a term Parkinsonian disorder is one that is characterized by the presence of slowness, stiffness of movement, and tremor. The most common Parkinsonian disorder is Parkinson's disease. However, there are several others. There are at least 3 or 4: dementia with Lewy bodies, multiple system atrophy, progressive supranuclear palsy. Two of these disorders, dementia with Lewy bodies and multiple system atrophy, share with Parkinson's the presence of Lewy bodies, or the component of Lewy bodies called synuclein. So another area of research is trying to understand these diseases across diseases, to really understand the role of this protein in these various degenerative disorders that lead to Parkinsonism. And why is it that if synuclein is causing all of them, some people have dementia, some people have multiple system atrophy, and some people have Parkinson's? We don't understand that either. Right now, the research studies we spoke about today are predominantly or strictly focused on individuals with Parkinson's disease. I think future studies, especially ones that look at the protein synuclein, will extend to other disorders that are marked by Lewy bodies or other structures in which synuclein is present. And I really believe that eventually therapies targeting one of these disorders is going to benefit the rest because there is a shared mechanism to all of them. They may be different clinically and there are important differences. But I'm optimistic, again, that many more people will benefit than the groups we're just studying right now.
Thank you. Thank you all for being here tonight. Please join me in thanking our speakers. If you would like to learn more about the work that the Jewish Home family is doing on Parkinson's, please make sure that we have your contact information and your email before you leave. Ezra is in the back of the room. He's waving. He's the key person to make sure he has your contact information because he will get you any and all information. And again, thank you so much for being here tonight.